The question says we should simplify this rational expression. So we have minus x times y raised to the power 3 times z raised to the power 4 divided by, okay, in the brackets we have xy raised to the power 3 times z raised to the power 6, everything is power minus 2. How do we simplify this solution? Okay, so here we have minus xy raised to the power 3 times x raised to the power 4 over x y raised to the power 3 times z raised to the power 6, okay, is power minus 2, okay. So let us recall one of the law of indices. When we are multiplying the same base, we are multiplying different base, okay, with the same exponents, okay. So we multiply the base, okay, and we pick one of the exponents, okay. So let us apply this to the denominator. So for x y raised to the power 3, okay, times z raised to the power 6, everything is to the power minus 2. So we can have this as x y raised to the power 3, okay, raised to the power minus 2 times z raised to the power 6, okay, times minus 2. So from here, with x times y raised to the power 3 raised to the power minus 2, okay. So when we apply the exponent rule, okay, when we have something like this, okay, we pick out the base, we multiply the exponent. So when we apply it here, we have this as x raised to the power 1 times minus 2, okay, times y raised to the power 3 times minus 2, which gives us x raised to the power minus 2, y raised to the power 6, okay. Now for z, okay, raised to the power 6 raised to the power minus 2. So when we apply the exponent law here, we have z, okay, raised to the power 6 times minus 2, that gives us z raised to the power minus 12, okay. So when we come back here, since we have this to be minus 2 as the power, we have this to be minus 6, okay, as the power. So let us replace everything here with this. So we have this as x raised to the power minus 2, okay, y raised to the power minus 6, okay, times, for this we have this to be z raised to the power minus 12, okay. At this point, do not forget one of the law of indices that says anything raised to power that has a negative index, okay, we have this as 1 over a raised to power m. So we have minus m as the power, so we introduce 1 and we have this, okay. So when we apply this to this, for s raised to power minus 2, we have to be 1 over s squared times 1 over y raised to power 6, which is this, times 1 over z raised to power 12, okay. So let us come back here. We have this denominator to be minus x times y raised to power 3, okay, times z raised to power 4 over, okay. So for this, we have this to be this. So we easily look for the reciprocal of this, okay. So in this case, we have, for the denominator, we have this as 1 over s squared, okay, times 1 over y raised to power 6 times 1 over z raised to power 12. So the reciprocal of this gives us minus xy raised to power 3, z raised to power 4 at the numerator times, okay, this is s squared, okay, s squared, y raised to power 6, z raised to power 12, okay. Here we can apply our law further, the law of indices, okay. So for minus x times minus s squared, we have it to be minus x raised to power 1, okay, plus 2, okay. When you apply the multiplication law of indices, here you have this to be y raised to power 3, okay, plus 6, the same base, multiplying the same base, you add up, okay, and here you have this to be z raised to power 4 plus 12, which is this. So our final answer will be minus x, okay, for 1 plus 2 is 3, okay, y raised to power 9, 3 plus 6 is 9, okay, and this z raised to power 16. Thank you very much.